solving systems of equations, and our first method we used was graphing. So we solved by graphing on Thursday. Today we're going to be using the method called substitution. We probably did this in a previous class. Substitution just means to substitute one equation in for another variable. In order to do this, you have to have one variable on one side of the equation all by itself. So like here, you see we have y equals everything else. That y is all by itself. You have to have that in order to use this method. So if it's not like that, you're going to have to solve to get some letter all by itself. Okay, and if you also remember when we were doing graphing, there were three possible outcomes, right? We said that it could be one specific coordinate point where two lines crossed, and it was just the intersection point. We said that it could have been like parallel lines, and what was my answer if it was parallel lines? No solution, right, because they'll never cross. And then we had the type where it was the lines right on top of each other, right? And then our answer there was infinitely many solutions, right? Same thing here. You can have one coordinate point. So you could have some coordinate point, x, y. You could have no solution. Or you could have infinitely many solutions. First of all, if we solve and we get some value for x and some value for y, then we got this right here. If we solve our equations and we end up with, let's say, something like -6 equals 12, two numbers that do not actually equal each other, this is not a true statement, right? Then I have no solution. If I end up with my variables going away and I have something like 7 equals 7, which is a true statement, then I have infinitely many. All right? Okay, so like I said, if we are solving by substitution, we have to have one letter all by itself. The reason for that is because we only know how to solve for one variable at a time. Right? We can only get one letter completely solved for. So that means we're going to have to plug in or substitute in some piece for the other letter. So in example 1 here, the first equation they give us is y equals 3x plus 7. The other equation is x plus 2y equals 7. Well, they said that y equaled all of this over here. So that means I can take this and substitute it in for y in that bottom equation. So that's exactly what I'm going to do. So it says in the second equation here, I'm going to have to rewrite. I have x plus 2, but instead of y, I know that y is equal to all of this up here, right? So instead of y, I'm going to substitute in what we said y was equal to, 3x plus 7. Okay. And then we still write the rest of the equation. It says equals 7. Okay? And now we're just going to solve for x. So what would I need to do first? There we go. We got to distribute into that set of parentheses there. So I have x, and then I've got 2 times 3x. What's that going to give me? So I've got plus 6x. And then 2 times 7. Good. Equals 7, right? Okay, now we would need to combine our like terms. So I have an x and a 6x all together. That gives me, so I've got 7x plus 14 equals 7. Okay, now what would I need to do? Subtract 14. So I subtract 14 from both sides. And so now I have 7x equals, what is 7 minus 14? Good job. And then what would I do? Divide by 7, so I'm going to end up with x equals -1. Very good. All right, so I found some x value, right? But we said we also have to find y. So now what I can do is substitute negative 1 into one of my equations for x. I'm probably going to want to plug it into that top one because it's already set equal to y, right? So I'm going to rewrite that first equation. It's going to be y equals 3, but instead of x, I plug in negative 1 plus 7. Okay? And what is 3 times negative 1? So I really have negative 3 plus 7, which is going to give me 4. Okay, so here's some x value. Here's some y value. So, like we wrote up here at the top, I found a coordinate point, right? So here's my x, and here's my y. So there is my answer. All right. Okay, so let's do another one. On example 2, we've got y equals 2x plus 5 and y equals x minus 1. This one has both of the y's solved for, right? So either way, I'm plugging one into the other. So anywhere there's a y in that second equation, I'm going to plug in 2x plus 5. So the first thing I come across is a y. So I've got 2x plus 5 equals x minus 1. Okay? So if I'm going to solve this, what do I do first? Good. I'm probably going to want to move this x over here. So 2x minus x leaves me with 1x. Then I got to move the 5 to the other side. How would I do that? And negative 1 minus 5 gives me, good. Okay, so I found my x value. Now I have to find y. Well, I can plug it into either one of those equations. Which one would you guys like to plug it into, the first or second? Okay. So I would have y equals, instead of x, I plug in negative 6. And I have minus 1. Well, it is negative 6 minus 1. Very good. And there's my y value. So again, we found an x and we found a y. So I can write those as a coordinate point. Negative 6, negative 7. Example 3, we've got 2x minus 4y equals negative 3, and x equals 2 plus 2y. So they do have one that has the letter all by itself. So that means I'm plugging which one into which one?
2 into 1.
Right. I've got to plug this one into the top one. It has the x all by itself. That way we don't have to do any solving, right? So that just means anywhere there is an x in the first equation, I get to plug in what we said x is equal to. So if I rewrite that first equation, I've got 2 times, instead of x, 2 plus 2y, and we still have a minus 4y equals negative 3 in that top line. So all I did was, instead of the x, plug in what we said x is equal to. Okay, so what would I need to do first here? Good. So 2 times 2 plus 2 times 2y. Good. Okay, and then now what would we need to do? Combine like terms. And what is 4y minus 4y? 0, right? These go away. So now all I have left is 4 equals negative 3. Well, Well, does 4 equal negative 3?
No.
So my answer must be good. Okay. All right. Example 4. We have r equals t minus 5 and negative 2r plus t equals 4. So since the top one has already got the variable by itself, we must be plugging the top one into the bottom. Very good. So anywhere there is an r in the bottom equation, we get to replace it with t minus 5. So I start rewriting that bottom equation. I've got negative 2 times, instead of r, plus t equals 4. Okay? So what should we do first? Good. So negative 2 times t gives me negative 2t. And then negative 2 times negative 5 is going to give us positive 10. Very good. And we still have plus t equals 4. Okay? So now what should we do? Right. I've got negative 2t and positive t. If I put those together, I'm left with, very good, plus 10 equals 4. So now I have to move that 10 to the other side, right? So I would have to subtract. So now I have negative t equals, very good. Okay. And we don't like a negative in front of our variable. How do I get rid of that? Good. So I'm going to end up with t equals positive 6. Right? Okay. And now I've got to find r. R in that top equation is already solved for. So I'm just going to substitute 6 in for t. So I'll have r equals, instead of t, 6 minus 5. Okay, and what is 6 minus 5? Okay, so we have t equals 6 and r equals 1. They're not x and y, so to make sure we write them as the correct coordinate point, you go in alphabetical order. So which letter would I need to put first? R. So I would put 1, 6. Okay, I want you guys to try numbers 5 and 6, and then we'll check them together. So on number 5, which one did we plug into which? Right, top one into the bottom one. So anywhere there's a y in the second equation, we got to plug in 2x plus 5, right? So I just rewrote it, 4x plus, instead of y, 2x plus 5 equals 2. Okay, then what do you guys do first? Good. So 4x and 2x. Okay, and then what? Minus 5 from both sides. So I end up with 6x equals negative 3. And then what we do? Good. Which is going to simplify to negative a half, or negative 0.5, right? Make sure that you write your final answer as a fraction if you convert it to a decimal when you're solving, okay? All right, and then I just plug this into either one of those equations at the top. It's probably going to be easier if we plug it into the top one, right? So I'll have y equals 2. Instead of x, I plug in negative 1/2 plus 5. So what is 2 times negative 1/2? Negative 1 plus 5, and what is negative 1 plus 5? here is our x value, and here is our y value. Now I just need to write it as a coordinate point. So -1/2, -4. Okay? Okay, example 6. We have them both solved, so you can plug either one into either one. So just going to replace the y, so I'll have x plus 4 equals -2x plus 11. So what do you guys do first? Let me move. Very good. So now I'm going to have 3x. Now I got to move the 4 over, right? So 3x equals 7. Okay, so now I have 3x equals 7. I just divide by 3. So I end up with x equals 7/3. Now I just take this, plug it into one of my equations up here. So I'll have y is equal to 7/3 plus 4. You can put that in your calculator, or if you wanted to get a common denominator, you just need this to be over a 3. So I'd have to multiply the top by 3, which would be 12. 12 plus 7 would be 19. So we'd end up with 19/3. Okay, and there's my x, and here's my y. So there is my coordinate point. So we didn't come across one of these. We did come across a no solution one, right? That's when the numbers were different. If you do the same thing, but let's say we had gotten 4 equals 4, then our answer would have been infinitely many. Okay, any questions on these?